Hello, welcome to Electron. As you can see here, the main activity of the company is design and production of electrical and electronic equipment for laboratories of schools of any degree up to university. And today I am going to describe to you one of its main proposals, what we call the Electrical Machines Laboratory. What is it? It is a comprehensive collection of compatible, easily connectable and integrated educational components with the purpose of implementing a machine test facility. The components, which I will show you later on, some of them at least, because there is a very long list of available components, are machines, transformers, single and three-phase, induction machines, single and three-phase, AC synchronous machines, DC machines. Mind you, the standard power of these machines are 300 watts, 1 kilowatts and 3 kilowatts. But other ranges are available on request. Then we have a set of instruments. Of course, we need instruments to measure all kinds of electrical parameters, to measure speed and to measure torque. Then we have a set of what I call ancillary components, power supplies, of course, because we need to give power to all these pieces. We need loads to load the generators. We need brakes to brake the motors. There is a paralleling board. This is going to be used when we need to make a parallel of 2 3-phase lines, and then some others that are, for instance, cables, coupling board, furniture of any kind, I mean tables, cabinets, stools, and even a rack on which some instruments can be mounted. Then, last but not least, we have documentation, which is very important. There is a laboratory instruction manual. This is a more than 150 pages manual that describes in detail the tests that can be performed with all this equipment. Then there are user manuals. Each of the complex components have their own manuals. Then there is a special manual which shows results, typical results, that are to the instructor. They are available for instructor use as a reference. And then at the end we will go through an exercise. We will do a test just to show how all the things come together. We start from transformers. This is a single-phase transformer, and as you can see, it has a primary which is divided into 2 phases, as well as the secondary that will give maximum flexibility for connecting the transformer in different ways. This is a 3-phase transformer. Primary is up here, secondary is down here. And again, the phases are split in 2 so that you can connect them in different ways for different voltages and in different methods. Star, delta, zigzag, and so on and so forth. This is a single-phase capacitor motor. Now, I wish to point out a common characteristic of the terminal boards, that, as you can see, first of all, they are equipped with 4mm safety connectors. Then, as much as possible, we try to represent in the drawing the logic which is inside the unit. For instance, in this case, single-phase motor, we have a main winding and an auxiliary winding and a capacitor. Therefore, when the student connects this unit, he knows exactly what he is doing. He doesn't have to remember or guess, simply follows the logic, which is even better represented by this motor, which is a slip ring motor. You can see the three-phase stator with the three phases, and the rotor, the three windings of the rotor. Again, you see the drawing here, which is the good representation of the motor inside. Its logic is very apparent here. Even better on this one, which is a two-speed so-called Dalander motor. Now, one connection allows you to drive it at 4 poles, and here is the representation of that connection. The other kind of connection, which by the way is called a double star, makes the motor a 2 poles motor for double speed. Here we have a universal motor. The universal motor can be supplied with AC or DC. There are 2 windings, as you can see here, and according to the kind of power, the windings are connected in series with the stator, with the armature that ends up at these 2 connectors. Oh, I didn't mention before, but I will do it now, that in any case you must remember to connect the ground for safety reasons. Okay, always do that.